Hi, this is Mark Struthers. Let's explore some solutions for workflow in radiology. We'd like to present a 5-step medical imaging workflow process for building solutions in your department. Workflow is identifying people, systems, and interactions that are involved in producing a specific task or outcome. We'll start with the patient going to the doctor, and the doctor orders some images. The ordering physician receives the images and a report from the radiologist and then proceeds to treat the patient. Now let's look at a traditional workflow series in medical radiography. Remember, it's an implementation-specific mechanism whereby a given process is realized and achieves its stated goal. Notice how many actors there are in this process and how many steps are taken. And this would be the minimum amount of steps taken for a traditional system. The first step in the 5-step program is to inform. You create an accurate before picture of what is to be accomplished. You define key metrics or measurements of accomplishments at specific points. You define the entire enterprise, the overall goal of the hospital or facility in specific terms, and the overall goal of the workers in specific terms. They should be defined with buzzword-free strategies. You don't need to say ASAP, as soon as possible, and other acronyms in your strategy to fulfill the goals of the workflow plan. Number 2 is to investigate or discover. You need to meet with the users to reconcile differences between the enterprise, say the hospital or corporate facility, the goals, and users' expectations. For example, the hospital might want to buy a 0.3 Tesla MRI unit, which is extremely slow and extremely outdated, but it's cheap. And the users need a 1.5 to 3.0 Tesla MRI unit to be able to get their job done. You must have a good idea about the enterprise itself, the infrastructure, and those who are participating in the workflow. After you have this understanding, you need to meet again with those participating in the workflow and calibrate their views and the information that you need. Finally, you provide recommendations that can reconcile any differences in the enterprise goals and the user's expectations. The third phase of the program is to create a plan. Build a tactical plan of action to meet the enterprise goals while satisfying the user's needs. Now we have 3 different perspectives in the plan: the enterprise, the actual users, and the person that wrote the plan. All of those have to go and work together to compromise and create an effective plan to put into action. So to do this, you create a project schedule specifying all the key objectives, and you schedule a review of key objectives as each milestone is met. Continually redefine your plan based on the feedback you get at each of the milestones, and create a working draft of the system architecture. Prior to implementing, create a technical prototype and see if the plan works. At this time, you can analyze and search for areas of risk or circumstances that will make the system perform poorly. Once that's done, you must build and test your solution. You create a test and maintenance plan to sustain the program. That includes test users and human factors, and then you deploy the solution. That done, you need to evaluate the plan. You need to revisit the goals and metrics set in the phase 1 and ask yourself, did we achieve the enterprise goals? Did we meet the user's expectations? And did we add value that we'd hoped we'd add? Then actively seek feedback of satisfaction from both the enterprise and the users. The questions are who, what, when, where, and why. If you can satisfy all of these, you have a good plan. Radiological processes consist of numerous, well-defined activities which are performed by different people or systems in different locations and at different points in time. In a digital department, most of these activities are supported by computerized application systems and appropriate software components within these systems. Managers guide and support workers in their tasks. Workers execute those tasks assigned by management to achieve the organization's goals. This is known as workflow. While the number of tasks in each workflow can vary from 8 to 80, every workflow is made up of 3 basic components. We begin with what triggers the workflow, or what makes it start, and that is the event that begins the workflow. This can be an action, decision, a specific time, or a response to something. The work is comprised of a number of tasks, or a series of tasks. The workflow includes all of the tasks, but it includes all of the people assigned to specific tasks and what is supposed to be done in the workflow to complete that task. The tasks are sequenced for the most efficient utilization of the different tasks in the workflow plan. The outcome of the workflow is the result of the plan. In 2023, there are several key trends in radiology workflow, and we're going to take a look at each of them. Of course, the first of these is the lean management principle. I can remember when I was a department head, my staff used to come to me and say, "We're understaffed, we need more people." My question was, did you get all the work done in the time that you were allotted? If you didn't get all the work done, we do need more staff, but if you did, you're just working hard. One of the basic keys for efficiency is interoperability of all of the modalities with the administration for all the modalities and the cybersecurity to focus on making sure that the integration between these systems is seamless and that we get the correct patient data. The next is the use of electronic work lists for both the technologist and the radiologist. For the radiologist, there's also voice recognition software. Dictation is rapidly becoming a thing of the past as radiology moves toward voice recognition automated transcription directly into the reports. Artificial intelligence is incorporated into not only the radiologist's workflow, but into the technologist's workflow, and we have many fully automated rooms at this time. These rooms have auto-positioning and auto-tracking as well as incorporated smart systems to help with everything from technique selection to positioning. For the patient and the physicians, we store our images on the MIMS system, which used to be PACS, and also we use the vendor neutral archive, which is a cloud system that you can subscribe to that allows access from anyone, anywhere, at any time to the images because it's all been standardized. Why the need for all this workflow and computerization? Well, think about it. In radiology departments, we often manage multiple systems and multiple workflows, which can be complex even at the most simple of times. In addition to that, we have technologists acquiring images at multiple different sites, from the diagnostic department to the ER to surgeries, and all over the hospital utilizing portable equipment. Each of these different actions require a different workflow and a set of tasks coordinating the workflow to be done. First, we acquire the images using image-based tasks. The images are sent to the radiologist for interpretation and creating a diagnostic analysis or report. The end result is we can integrate all of the information from the different diagnostic modalities to create reports for specific patients that are generated to the physician and then to the patient. So let's review that process. The modalities send images to the PACS server, or the MIMS, where the radiologist gets the images to interpret. When the radiologist has finished interpreting the images, they send it back to the PACS server that can be accessed by the hospital information system, different workstations, physicians, and different radiologists, and also the receivers of the retrieved images. So let's look at radiology workflow in the context of digital imaging, and it involves several steps, beginning with scheduling and preparation, then image acquisition, then image and data interpretation by the radiologist. The physician receives the information, and the outcomes and the follow-up are based on the interpretation, and a treatment plan or an effective follow-up care is scheduled for the patient. With today's technology, the patient can access their reports and images online if available. This chart shows, or this slide shows, our process of change from a manual system to a computerized system. So what is a task in workflow? It is a process and/or a procedure in which tasks are completed. A workflow is a reliably repeatable pattern of activity enabled by a systematic organization of resources, defined roles that can be documented and learned. Workflow is the automation of a process in whole or part during which documents, information, or work items are passed from one participant to another. Current IT solutions in radiology are predominantly data-focused and do not provide sufficient support for workflow. With the use of AI, we're actually able to improve the physical workflow for the technologist in acquiring medical images. As the technology evolves, this will become more and more predominant. We've progressed from isolated systems into integrated technology, where we can deliver images anytime, any place. We have systematic management and control of the data. It has been consolidated and can be delivered in real time. Workflow refers to how data will move through the department, and computers are very picky about information, unlike humans. In the workflow, the key today is the accession number and the patient's ID. They play a crucial role in our ability to store items and follow them as they move through the department. The accession number and the medical record number allow unambiguous association of the image data set with the correct patient demographics. This also allows coordination of the patient's scheduling and an image encounter at the imaging modality. This is all made possible by different computer languages that are unique, such as HL7, which stands for Hospital Language 7. The hospital language is combined with DICOM. DICOM stands for Digital, Imaging, Communications, and Medicine. These two combine to make a rational database which is stored in the archive, or the MIMS or PACS, and allows us to transport the data seamlessly between one area and another. Remember, HL7 or HL7 Fire is hospital language, and DICOM is Digital Imaging, Communication, and Medicine. It is an international standard for exchange, storage, and communication of digital medical images and other related data. AI can be used for medical imaging analysis. It provides pre-analysis of radiology images, helping to detect and classify abnormalities. This includes using AI algorithms to extract features from images that would be invisible to the human eye. It can also be used for computer-assisted triage. AI helps prioritize reporting work lists when an abnormality is detected. AI algorithms can also be used for streamlining workflow for both the radiologist and the technologist. It can be used for patient scheduling, and also AI could target different radiology modalities and workflows to make processes more efficient and reduce staff burnout and cut costs. So we can all agree to these workflow changes might be very positive, but there will be a lot of resistance to change in both the administration and the workers who utilize the systems. Users have fear and uncertainty, a lack of awareness. They also mistrust and lack of confidence in both the systems and the computers. They may have emotional changes such as fear of losing their job. Another great fear is that the existing organizational culture will have to change. Thanks for watching the Mark Struthers channel.